Hey guys, let's look at our second set of problems here from our test. So I'm looking at problem 14 and also at problem 2. So if I look at problem 14 first, it says a graph of, and it gives you the function, is shown on the grid. What are the zeros of f? Well, if I look at my graph, the f right here in the question is just saying that this line, they're going to call it f, okay? And let's see, my keyword is zeros. So I got to remember what zeros are. So if I scroll up to slide 5, I have my notes and I have a note on 0. So 0 is equal to the x-intercept, meaning they're the exact same thing in this case. And if I look at a graph, I see that my zeros are pointing to these two numbers, 1 and 9, and it happens to be at the x-axis. And that is usually where I find my zeros or my x-intercepts. So when I go back to my graph for number 11, I'm looking basically where does this equation reach that x-axis at? Basically, it's kind of like where it intersects at. So a couple of things that I can do is I can actually plug that equation into my calculator, or I can just look at this graph here. So if I look at the graph, I got to look for when the parabola intersects with the 0 or the x-axis. So let's see, I'm going to put some arrows where it intersects. And that would be one right here. I'm going to make that red. So there's one of them at this point, and then I have another one right here next to it, actually. Make that one red too. So I notice that here I have actually 2 zeros. So if I have 2 zeros, that should help me to realize, okay, I can cancel out some answer choices here. So I'm going to cancel out F and G. Okay. And then I look at these numbers themselves. So the first 0 is between 0 and 1. So that means the first 0 has to be less than 1. And the second 0 is between 1 and 2. So that 0 has to be less than 2. And if I look at the two answer choices that I have left, the only one that makes sense is the last one with our fractions, saying 1/3 and 3/2. So those are probably my zeros. Okay. Now, zeros, another word for zeros is solutions. Okay. Now, part of the zeros and the fact that we find the zeros on the x-axis is because that's where they intersect with the x-axis. Please pardon the interruption. Okay, so like I was saying, that the 0 is where it intersects with the x-axis. Okay, so my equation intersects there. Now, if I look at number 2, what are the solutions to the equation? And it gives us the equation is equal to 18. So my keyword is solutions. Solutions. Okay, and so I'm going to make that one blue. All right, so solutions also can mean x-intercept sometimes. Okay, and in this case I have two equations, 3x squared plus 15x equals 18. All right, so basically I want to know when these two equations kind of intersect each other. And it's going to tell me here, if I look at my answer choices, these are kind of the numbers that I want to be looking for when I plug that into my calculator. So I have, let's see, 3x squared plus 15x for my first equation. And then it's equal to 18, so I want to set that equal to 18. Okay, so let me hit graph and let's see what this looks like. There's our blue line, and it looks like I can't see my red line, so I'm going to want to zoom out. And there it is. Okay, so I want to know when these two lines are equaling each other or intersecting, basically, right? So the best way to look is at our table. And if I, well, before I go look at my table, if I notice here, the first intersection happens on the negative side. So when I go to my table, I'm going to want to go up into the negatives and find out when my equations are kind of equal to each other. And looks like I just found one of them. When x is negative 6, both of my y's happen to be 18. Both of them are positive. Don't get that mixed up with this part right here. When x is negative 3 and negative 2, the y is negative 18, but these are positive 18. Those are not the same number. Okay. So I know one of my intersections or one of my solutions happens to be negative when x is negative 6. And if I look at my answer choices, it looks like there's only one, but let's just double check that the other one is supposed to be 1. So when I go back to my calculator, when x is 1, yep, both 18. And that is how I find my solutions. So basically, how would we have solved these problems similarly? Is we are looking for when the quadratic intersects with the solutions. And in the first case for number 14, they wanted the parabola to intersect with when y is equal to 0. And number 2 wanted the parabola to intersect when y is equal to 18.